Welcome to the traumatic brain injury section on mathematics. The most important part of mathematics is relearning that rogue mathematics. Many times when the student gets injured with traumatic brain injury, even though they may have been very efficient with their mathematics basic skills, now they aren't. So what you want to do is make it as fun as possible for them to get that rogue mathematics back. So one of the things that I recommend is to utilize the computer, flashcards, anything fun, games, etc. On the website, underneath this video, you will see some websites that I recommend. I'm also going to have a little video at the end that gives you an idea of my two favorites, which is coolmath.com, and I like the Freebit feed, and that's for addition and subtraction. And then I also like the Big Brains, which is part of Cool Math, and it has all of them. It has addition, subtraction, multiplication, and division, and they actually run through a maze. It's free. You can buy an upgrade, and they can go to other places like Planets and things like that, which is also wonderful. But today's lesson that we're going to be working on is probably something that all kids struggle with, not just kids who are in resource or students with special needs. It's ratios. And as you know, ratios are the #1 thing that kids have problems with, and that corresponds back to your fractions. So the first thing that I always do is preload the vocabulary for ratios. I also like to mention that ratio is written as a fraction, 1 to 2, 1 to 2, or 1 to 2. So we have 1 over 2, or 1 to 2, 1, 2, as in T-O, 2, and 1 with a colon, 2. That's all what a ratio is. The actual lesson that I'm going to demonstrate is going to be that whole concept of mind, seeing it, hearing it, and touching it. So here we go. So the first thing I want you to do is tell me, what are the colors that are here?
Green and purple.
Green and purple, great. How many are here on each of them? Count them out loud for me.
2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28.
That was great. I really like the way you counted them in twos. But now what I want you to do is count them across for the green first and then the purple.
8, 10, 12, 14.
14. Yeah, 14, what color?
Purple and 14 green.
And 14 green. Okay, I want you to, now what we're going to do is, what's the very first number on here?
2 to 3.
2 to 3. So which do you want to do? Do you want to do purple? Or the first thing we're going to do is, what does this say?
2 to 3.
So which do you want to do? Purple or green for 2?
Green.
Green. All right.
Go ahead.
So are we going to do a ratio of green to purple, or would it be purple to green?
Green to purple.
Green to purple. So let's look at that one more time. Okay, you said green to purple. Which number's first?
2.
So 2 is what color?
Purple.
So it would be purple to green. So remember when we looked up on the board, the ratios up here would be 1 to 2, 1 to 2, 1 to 2. Doesn't matter, they're all the same, but it's just how they're written that's different, okay? So when we look here, this says 2 to 3. So we have 2 to 3. What would the next pattern be if we wanted to do another 2 to 3? What would that look like?
It would just be 3 purple, 2 green.
We want them to be exactly the same.
Oh, in that case.
There you go. So how many do we have total now?
10.
10. So let's do another set. And how many do we have now?
15.
Great, let's do one more. So now, if we have, how many on the top?
8.
So 8 purple, right? So let's put 8 there. And how many green do we have?
12.
12. And I want you to put a P here for purple. How many do we have all together?
20.
20. That is exactly correct. Now, let's start over. And you get to turn these around.